This is the review for AP Chemistry Unit 6. These are the topics. First, we are reviewing the 4 variables that we will use in this unit, which are pressure, volume, amount, and temperature. So pressure is the force that the gas exerts on the walls of the container. Barometer measures the atmospheric pressure. 1 atm equals 760 millimeter mercury, which equals 760 torr, which equals 101.325 kilopascal. And volume is represented by the letter V, and 1 centimeter cubed equals 1 milliliter, and 1 meter cubed equals 1,000 liters. It is the quantity of space occupied by the gas. Amount is represented by the moles in chemistry, so even though it gives you the grams, you always have to convert them into the moles, and it is the only standard metric unit for the amount. 1 mole equals 6.02 E23 particles. 1 mole of any gas occupies 22.4 liters at STP. If it's not at STP, you'll have to use the ideal gas we will learn today. Next is the temperature, represented by the letter T, and it is the measure of internal energy of a system, while heat is just a measure of how energy is transferred from one system to another. So you are also using the unit of Kelvin, not the Celsius. Kelvin equals Celsius plus 273. Next is gas laws, and we will go through 4 gas laws today. First is the Boyle's law, which deals with pressure and volume, and P1 V1 equals P2 V2 when temperature is constant. Pressure and volume is inversely proportional, so if the pressure is large, the volume will be small. And you can think of it as if you exert the pressure, the volume will decrease. And you have a practice question here. The volume of gas at 1.10 atm was 326 milliliter. What will be the volume at 1.90 atm? So you're simply using the equation here, and P1 was 1.10 atm. And then V1 was 326 milliliter equals the P2, which was 1.90 atm, the V2, which you are looking for. So you have to divide both sides with 1.90, and then you get the volume of 189 milliliter. Next is the Charles law. You will also be very familiar with this. And this law deals with temperature and volume. They are directly proportional, so as the temperature increases, the volume will increase as well. The question asks, at 189 Kelvin, a gas has a volume of 32.0 milliliter. What's the volume at 242 Kelvin? So you use the equation here. And initial volume was 32.0 milliliter over temperature 189 Kelvin equals the volume over 242 Kelvin. You do the calculation, you get the volume of 41.0 milliliter. And you have to make sure that the temperature is in Kelvin, because the question might give you the temperatures in degrees Celsius, but you always have to convert them into the Kelvin. Next are the Gay-Lussac's law and the Avogadro's law. Gay-Lussac's law deals with pressure and temperature. Pressure and temperature are directly proportional, so this graph shows that as temperature increases, the pressure Y values increases. And Avogadro's law deals with the amount and the volume. So number of moles and volumes are directly related as well. So as the number of molecules increases, the volume will increase as well. Next is the combined gas law, and this deals with all 3 variables: pressure, volume, and temperature. So if the question gives you the values for all 3 variables and asks for one of them, you should use the combined gas law. It asks 250 milliliter of gas at 100 degrees Celsius and 740.0 millimeter mercury are there. If the gas expands to 500.0 milliliter and pressure is lowered to 705 milliliter mercury, what's the new temperature? So it gives a value for volume, temperature, and pressure. And here volume, pressure, and asks for temperature. So you have to set up the equation. So P, which was 740.0 millimeter mercury, times volume, 250.0 milliliter, over the temperature, 100 degrees Celsius. But you have to make sure that it is in Kelvin. So it will be plus 273 Kelvin equals the pressure times the volume over the new temperature, so T2. And you simply have to do a calculation and you get the temperature of 711 kelvins. And the units for all other variables than temperature can be anything, but they have to be matching with each other. Next is the ideal gas law, which is a very important or the most important topic in this unit, and it is used in non-standard conditions, so non-STP. So if the condition is at STP, you can use the other gas laws that we just went over. But if it's a non-STP, you will have to use the ideal gas law, which is PV equals nRT. So the unit for volume has to be liters. And for amount, it has to be moles. And for temperature, it has to be Kelvin as well. But the unit for pressure can be anything like ATM, millimeter mercury, or kPascal. But as you use a different unit for pressure, you have to make sure that you're using a different value for R as well, because R value depends on the unit of pressure. And also, derived from the ideal gas equation, you know that molar mass equals density over P times RT. And it will be easy for you guys to memorize this equation because it will take a pretty long time for you to derive from this ideal gas law on the test. We have a practice here. It asks a 1.00 liter container is filled with propane gas at 101.3 kilopascal and negative 20.3 degrees Celsius. What is the mass of the propane in the container? So it is asking for the mass. So you'll have to find the moles first and then convert it into the mass. So in order to find the moles, it is in a non-STP, so you have to use the ideal gas law. Ideal gas law is PV equals nRT, and you're looking for the moles. So N equals PV over RT, which is 101.3 kilopascal times volume, which was 1.00 liter, then over the R. And as we just went over, you have to make sure you're using the right value for R. And in this case, it will be 8.31 because you're using kilopascal for pressure. So it will be 8.31 times the temperature. And it gave you the temperature in Celsius, so you have to do plus 273 to make it in Kelvin, which gives you 252.7 Kelvin. And then you get the answer of 0.0482 moles. Then it asks for the mass, so you have to convert it into the mass. Propane times the molar mass, which is 44.097 grams per mole, Then you get the answer of 2.13 grams propane. We have another example. What volume of carbon dioxide can be produced when 68 grams of CH3OH burns at 25 degrees Celsius and at 1.02 atm? So you're also using the ideal gas law. You first have to write the equation. And you have to make sure that you balance the equation. H2O, because this is the combustion reaction, and combustion reaction produces carbon dioxide and water. If you balance the reaction, it will be 2, 3, 2, and 4. And it gave you the mass for CH3OH, so you have to convert that into the moles first. 68 grams divided by molar mass, grams per mole. This is for CH3OH, so you have to multiply by the molar ratio from this balanced equation to convert this into the moles for carbon dioxide, because carbon dioxide is what you're looking for. So you have 2 moles of CH3OH and 2 moles of carbon dioxide, because you have the coefficient of 2 for both. Then you get 2.1 moles of carbon dioxide. And it is asking for the volume, so you are using the ideal gas law. So PV equals nRT. Then for volume, it equals nRT over P, which is 2.1 moles, which you got in here, times, you have the unit of atm for R, so you are using 0.0821, and then 298 for temperature over 1.02. And then you finally get the answer of 50 liters carbon dioxide. You have 2 sig figs here.